In the last video, we discussed potential and kinetic energy, but how do these ideas relate back to chemistry? As a hint, remember that atoms are made up of charged particles, and they can move. Since atoms are made up of charged particles, the electrostatic force is important, and we can understand atomic interactions in terms of the electrostatic attractions and repulsions as explained by Coulomb's law. Essentially, atoms need to quote-unquote stick together to make molecules, to form solids from liquids, or to form liquids from gases. Clearly, there must be some kind of mechanism by which this takes place. Here, we have the model of the atom used throughout these materials so far. The shading you see in the representation is for showing electron density caused by the movement of electrons. The electron cloud can fluctuate momentarily, so that way the electron density is distorted. The image here shows how the electron cloud can be distorted, and as the electron cloud distorts, it creates a separation of charge. This separation of charge can cause the electrons to be temporarily located more on one side of the atom as compared to the other, creating a partial negative and partial positive regions of the atom. This is referred to as a temporary dipole. This atom can then induce a temporary dipole in a neighboring atom, and atoms can attract one another. So let's think about if the world was made of only isolated atoms, what would be the consequences? Well, the atoms would constantly bounce off each other, transferring energy with each collision. However, this does not help us explain the differences in phenomena that we observe. Let's go back to how atoms come together or interact during each phenomenon, such as the formation of molecules, freezing, and maybe even condensation. Remember that the melting point of a substance is the temperature that the substance changes from solid to liquid, and the boiling point of a substance is the temperature at which that substance changes from a liquid to a gas. Helium, as well as other noble gases, do not really react with anything. It has a melting point of 0.95 Kelvin and a boiling point of 4.5 Kelvin. In order to observe the properties such as boiling and melting points, there must be large numbers of helium atoms that are stuck together. Think about what you know about a solid. The atoms are tightly packed, so there must be something to make these atoms stick together. As we wrap up this video, I'll leave you with a brief exercise to consider. In your notebooks, draw a picture of about 20 helium atoms in the solid, liquid, and gaseous phases. Respectively, think about why the atoms in the solid helium do not fly apart. As you think about your drawings, consider how the atoms are arranged in each state. Are they uniformly packed together, or are they touching but free to move about? How might these atoms be interacting? Are they far apart from one another and don't seem to be interacting, or are they locked in a rigid position with strong interactions between them? Try to relate what you drew to the ideas of potential and kinetic energy presented in the previous video. How might we relate these two forms of energy to the strength, number, and types of interactions between species?